Okay, today we discuss about the topic of assignment problem. And assignment problem, we have the special cases and maximization and minimization and unsupervised and supervised unbalanced assignment problem and balanced assignment problem we have to see. So introduction, this is an introduction of assignment problem. The assignment problem deals with allocating various resources to various activities on one-to-one basis in the number of operations are to be assigned to an equal number of operator, which each operator performs only one operation. For example, suppose an account officer have 4 subordinate and 4 tasks. The subordinate different in efficiency and have take different time to perform each task. If one task will be assigned to one person in such a way that the total person hours and minutes minimize the problem is called an assignment problem. So in that following the objectives will be followed. Formulate an assignment problems and determine the optimal solution of assignment problems using the Hungarian method. Obtain the solution from special cases of assignment problem and maximization problem, unbalanced assignment problem, alternative optimal solution, and restriction of an assignments. So in traveling salesman problem, we have to see with the next problem, next video we have to see, and then traveling salesman also we have to using with the assignment cases. So then assignment problems and its solutions. So the assignment problems may be considered as special type of transformation problems in which number of sources and destinations are equal. The capacity of each source as well as the requirement of each destination is taken as one. So in case an assignment problem, the given matrix necessary be a square matrix, which is not conditioned for a transportation problem. Suppose there are n persons and n jobs, and the assignment of jobs has to be done on a one-to-one basis. The assignment problem can be started in the form of n cross n matrix of real numbers. That is a cost matrix. So this is a cost matrix. So cost can be assigned with the column wise and row wise, and n persons will be there. So n jobs can be assigned. This is a mathematical calculation formula. That is a minimum of z equal to I1 to n. That is a column, and J1 to m, that is a row, and CIG cost will be calculated with the number of persons to number of column rows. So this is a parameter of that one, and this is a Hungarian method how to solve that. Obtaining an optimal solution of assignment problem. There are either a given matrix is square. Check whether the given matrix is square. If not square, by adding a situation number of dummy rows with a zero cost matrix. Locate the smallest cost element in each row of the matrix. Subtract the smallest element of each row of every element of that row. The resulting cost matrix, locate the smallest element in each column and subtract the smallest element of each column from every element of that column. In the resulting matrix, search of an optimum assignment as follows. Examine the row successfully until a row with exactly 1 0 is found. Draw a rectangle around the 0. If the 0 is corresponding column, proceed in the manner until row having been examined. If there is more than 1 0, if any row do not touch that row, pass on the next row. Repeat step above the column of the resulting cost matrix. If the row or column of the reduced matrix contains more than 1 zeros, arbitrarily chosen a row or column having the minimum number of zeros. Arbitrarily select any zeros in the row or column to choose and draw a rectangle around it and cross out all the zeros in the corresponding row and column. Repeat step 1, 2, 3 until all zeros have either be assigned or closed. So step 5, draw the minimum number of horizontal and vertical lines through all zeros as follows. Tick mark. Tick mark rows in which assigned has not been made. A tick mark column which has zeros are marked by rows, and tick mark rows which have assignment is marked column, and then tick mark column which have zeros newly marked rows. If any tick mark rows already marked which has assigned in newly marked column. Draw straight line through all unmarked rows and marked columns. Revise the cost matrix. Find the smallest element not covered by an element line. Subtract the from uncovered element by add the element. Interaction of two lines. Other element covered by the lines remain unchanged. Repeat the step and finally optimize the method. So example one, so computer center has 4 expert programs and need to develop 4 application programming. The head of the computer element estimates the computer time required by the respective experts develop the application program as follows. And program standards 1, 2, 3, 4. The value will be 120, 100, 80, 90, and 80, 90, 110, 70, 110, 140, 120, 100, 90, 90, 80, 90. Solutions. So, first of all, the given value, first of all, whether the given problem is balanced or unbalanced, there are 4 rows and 4 columns. Given the problem is balanced, then we move with the row minimum. So row minimum, we have to, each row, we have to consider the small element and then we subtract from all the elements from that element. So for 80 is the smallest element. So 120 minus 80, 100 minus 80, 80 minus 80, or 90 minus 80. So the answer will be 40, 20, 0, 10. And second row, we have the minimum element 70. So 80 minus 70, 90 minus 70, 110 minus 70, 70 minus 70. The answer will be 10, 20, 40, 0. Third element, 110 is the minimum element. So 0, 40, 20, and 0. 100 is the minimum element. So 100, 110 minus 100, 0, 10, 30, 20, 0. Fourth row, we have the minimum element 80. So 90 minus 80, 90 minus 80, 80 minus 80, 90 minus 80. So then we saw a row minimum calculator. Then we find it with the column minimum. The column minimum, row minimum, what the answer is kept up, that answer only we have to reduce with the column minimum. So first column, A column having the minimum element 10. So minimum element we subtract from all the elements. So 40 minus 10, 10 minus 10, 0, 0. So 30, 0, 0, 0. So B element, minimum element will be 10. So subtract with all the element by 10. So 10, 20 minus 10, 20 minus 10, 40 minus 10. So 10, 10, 30, 0. So third and fourth column, we already have the 0. If any cost is 0, the minimum value is 0, subtract from the that 0, answer will be same value will be present. So the value will not be changed on column C and D. 0, 40, 20, 0, 10, 0, 0, 10. And then making an assignment, we consider row wise first minimum 0, only 1 0 available rows. So in column one, row, first row, we have the only 1 0, and remaining 2, 3, and 4 having the more than 1 0. So we have to skip with that. And once we find out with the row wise, and then we move with the column wise. And first column, we have the 3 0, so skip them. And second row, we have the second column, we have the only 1 0, so mark them. And the corresponding row and column, we have no zeros will be present. If the 0 is presented means we have to strike out. And third column also only 1 0, so 0 is marked. And then fourth column, we have the fourth column and column 1 and column 4 having the 2 zeros is there. So one first we choose with the column A, 2A we have to mark. 2A marked means, and 2D we strike out, and 3A also strike out. Once we selected the 0 on that row and that column, any zeros will not be present. So 2D and 3A have to strike out. Remaining will be in 3D only there, so we have to mark them. So the answer will be 1 tends to C, and 2 tends to A, 3 tends to D, and 4 tends to B. The value will be getted from 1 to C. First, given the problem only, we have to get the value, cost value. 1 to C, we have the cost value of 80, and 2 to A, we also have 80, 3 to D, we have the 100, and 4 to B having the 90. So totally 350 minutes, we have the solutions. And then second problem is a company is producing a single product, selling it through 5 agencies situated in different cities. All the sudden, there is a demand of problem in 5 more cities that do not have any agency of the computer. So the second problem also having the 5 rows and 5 columns. So 160, 130, 175, 190, 200, and 135. 120, 130, 160, 170, 140, 110, 155, 170, 185, and 50, 50, 80, and 80. 55, 35, 70, 80. So row first one we have to calculate with the balanced or unbalanced. So 5 rows and 5 columns. The ever given problem will be balanced. So second one we have to given with row minimum. Another first row we have to given minimum element will be the 130. So subtract from the 130 we get the answer from 30, 0, 45, 60, 70. And second row we have the minimum element from 120. So subtract from 120 the answer will be 15, 0, 10, 40, 55. Third row we have the minimum element of 110. So subtract from 110 we need the answer of 30, 0, 45, 60, 75. Fourth row we have the minimum element of 50. So 0, 0, 30, 30, 60. Fifth row we have the minimum element of 35. So 20, 0, 35, 45, 70. So once we completed the row minimum and column minimum, making an assignment will be followed with the next step. So third step will be the making an assignment. First row wise we have to check with the 1 zeros. So first row we have only 1 0, so mark them. And second row we have the more than 2 zeros, skip them. And third row we have the 1 0, so selected them. And fourth and fifth row, we have no zero. Fourth row we have multiple zeros, so skip them. On fifth row we have the zero is cancelled, so no zeros will be available. And column wise we have to check in at B1 having the only 1 0, so mark them. And corresponding row we have any zeros is that we strike out them. And second column we have already selected. Third column also 1 0, strike out from the remaining zeros in the column wise. And fourth column we have no zeros, and fifth column also having the no zeros. So and then now we apply with the Hungarian method. The Hungarian method before applying number of allocations will be uh, number of persons, reduced number of persons. So only here the 3 allocations only made it, but number of persons will be 5. So it will not be satisfied. So we have to apply with the Hungarian method. The Hungarian method first we already we had discussed with the Hungarian method. Unselected rows we have to tick mark, and in which row having the only 1 0 selected, that row and that column also selected, and selected column we strike out, and unselected rows we strike out. That is a Hungarian method. So in that problem, um, first row we have the selected zeros is there. Second row also we have the selected zeros is there. Third row we have not having that zeros, so we have to tick mark them. And fourth column we have the selected zero, so fifth row we have not selected, so tick mark them. And which row has the only 1 0 mark, that is in A, so tick mark them. That column also where the zero is assigned, column 2, so column 2 also tick. Strike out the column 2 and strike out the unselected rows. So now we find the applying the Hungarian methods. The unmarked rows, what are the element is that element, minimum element will be considered as subtractions, and intersecting lines we have to add the values. We find the smallest element matrix covered by 15 is that we subtract from the number of 15 from all the uncovered elements, and intersection of two lines we have to add the value of 15. So that's why 30 minus 15, 15. The 0 is marked line, so we have not change the value 0. And 35 minus 15, we have the answer 20. And 15 and 15 is a marked line, so we have to not change the value. That 0 is intersection the line, so we adding the value of 15 and 0, 10, 0, and 30 minus 15, 15, 0 straight out line, so we can't change. And 35 minus 15, 20, 15. 5, 20 minus 15, 5. And 0, 10, 20, 0, 5. 5, 0, 25 minus 15, 10, 0, 0. That will be 15 minus 15, 0. So 15 minus 15, 0. This will be a new converted form. Now we again apply for the um, making an assignment. First row we have the 2 zeros, so skip that. Second row also having the 2 zeros, and third row we have only 1 0, so mark them. And the corresponding column we have any zero is that we have strike out, and fourth column we have only 2 zeros is there, so skip them. Fifth row also having the 2 zeros, skip them. So then again we will follow move with column wise. Column wise we have the first column we have only 1 0, so mark them, and corresponding row any zero is the strike out. So D4 having the 1 0, that will be strike out. Column 2 already selected, and column 3 we find out to only 1 0, so mark them, and corresponding row any 0 is present at this, we select out them. And column 4 we have only 1 0 is there, so 0 is marked them. And finally uh, uh, in column 4 we have selected means if 5 or 0 is also cancelled, so here not marked, you have to cancel them, and only 1 0 is presented on column 5, and that is A5. So mark them. So the answer will be A to 5, B to 3, C to 2, and D to 1, and E to 4. So the value will be getting from the top of the problem. What the given is given A to 1, that value will be getting. A to 5, what the value is given means 200, and B to 3, 130, C to 2, 110, D to 150, E to 4, 80. So totally 570 kilometers. That's the thing. So answer. So in the assignment problem, another problem will be also available. That will be a maximization problem and minimization. Before we seeing the problem is minimization problem. If the problem is asking with the maximization problem, um, first same steps will be followed, but one thing will be the cost is maximization problem means first before the assigning unbalanced we have to convert into maximization cost. What the cost is given overall, that cost, which cost is higher value, that value will be subtracted to all the elements. Then we apply into balance or unbalanced and row minimum, column minimum, making an assignment and Hungarian have to apply. So this is a problem of unbalanced assignment problem. The above three problems will be given only row wise, column wise simulated problems, but here we have to given with unbalanced problems. In that unbalanced problem, here 5 rows is there, only 4 column is there. So the whether given problem is unbalanced. So first we added with the dummy rows or dummy columns on the corresponding column. So then we have to apply for step 1 to step 4, that is row minimum, column minimum, making an assignment. So row wise, we have the already 0 is minimum element, so the value will not be changed. Column wise, we have to changing means 10 is a minimum number, so 50 minus 10, 40, 30, 50. On column wise to second column, 20, 10, 0, 10, 0, 50, 30, 20, 10, 0. And 0, 10, 0, 10, 10, 0, 0, 0, 0 will be there. Now we assign first row we have only 1 0, and second row also having only 1 0, mark them. And third row we have only 0, so selected them. Fourth and fifth, fourth row we have not 0 is there. So fifth also only 1 0, mark them. So unselected row, tick mark them. And corresponding 1 0 will be available on 2 columns, that also we have to tick mark them. tick mark them, and then we find it with the value of 30, 10, 30, 10, and 20, 10, 10, 10. In the minimum value will be 10. So subtract them 40 minus 10, 20, 50, 0, 10, and 20, 0, 20, 0, 0, and 50, 0, 20, 0, 10, and 10, 0, 0, 0, 0, 0, 0, 10, 10. So Monday matrix is, Wednesday operation research, and Thursday will be discrete mathematics, and Friday is a statistics answer. The value will be given from the top of the given problems. The answer will be 20, 20, 20, and 10. So total answer will be 70. This is an optimization problems. That's all. Thank you. Ajit.